All right, last video for Unit 10, 10.4 Rate Laws and Rate Orders, Part 2. In Part 1, what we learned about was rate laws in general. We learned that, hey, if you have a reaction A goes to B, the rate law for this is going to be equal to just K times the concentration of A to the power of A. That's the rate law. And so we learned the generic form of rate law is how to write a rate law, which is basically the equation for the rate of a reaction. What we didn't learn is how to determine this exponent, right? The order of the reaction. Now that exponent, right, I put A there, it's just generic, right? It could have been X, Y, Z, right? It means it's some number there. It's, you know, in actuality, like 1 or 2 or 3 or 4, right? What we want to do is we want to learn to actually get the value of that. We want to determine the rate order by determining the value of the exponent. And so let's go over what that means. So for example, if A is equal to 0 up here, then we say that we have a 0 order reaction. If A is equal to 1, then we say we have a first order reaction. And if A is equal to 2, we say we have a second order reaction. Now do note that this is actually not just a value of the exponent, but it could be the exponents. So if, say for example, right, we have, I don't know, A plus B makes AB, right? And so in that situation, rate is equal to K times the concentration of A to the power of A with concentration of B to the power of B, right? And so here, it would be A plus B equal to 0, makes this a 0 order overall reaction, right? And so both of these are important in determining the rate order. You could also technically say, like, you know, let's say, for example, rate is equal to K to the power of A, which is first order, and then B, which is 0 order. We say that this is overall first order, but it's first order with respect to A and 0 order with respect to B. So there are nuances here, but overall, if A is equal to 0 or A plus B is equal to 0, we have a 0 order overall reaction. If A is equal to 1 or A plus B is equal to 1, we have a first order overall reaction. And if A is equal to 2 or A plus B is equal to 2, we have a second order overall reaction. And so that's what it means. That's what rate order means. Now, how do we determine rate order? And here's an example for us. Now, do note, rate order can only be determined experimentally, meaning you have to do an experiment, get data, and get it from that. That's the only way. There is no way to just like look at it, right? It has to be from data. And so let's take a look at this example and some experiment data. And so, you know, if we have this equation, we get this rate law for it. Now the problem is we want to figure out A and B. To do that, what some scientists did is they did 3 trials. And what they did is they changed the overall concentration of NO and H2. And then they measured the initial rate of the reaction. The reason for that, the reason why they're doing that is because basically actually 0 order, first order, and second order actually have meanings. So this is what the meanings are. So for example, 0 order reactions means that overall the reaction rate doesn't change even if we change the concentration of our reactants. The R1, which is our, you know, like reaction before, is going to be equal to R2, our reaction, and sorry, this should be reaction rate after, right? So reaction rate before is going to be equal to reaction rate after. And so basically, the speed, the rate of the reaction isn't going to change even if we change our concentrations. That's what it means to have a 0 order reaction. Whereas if you have a first order reaction, that means that if you double the concentration of your reactants, you're going to have double the reaction rate. And then lastly, if you have a second order reaction, that means that if you double the concentration of your reactants, R2 is going to quadruple. And so this is to the question of what happens to rate if we double concentration of reactant. So if R1 is equal to R2, then it's 0 order. If R2 is double R1, then it's first order. If R2 is quadruple R1, then it's second order. This is very hard. This is very confusing. I totally get it. There's a lot here. There's a lot to memorize. Watch this video multiple times if you need to. You're going to have to probably try to explain this to yourself Because again, there's just so much vocab here. But it's okay. We can do this. We can do this. It's just gonna take some work. And so let's take a look at this example. Right here, what we did is we doubled the concentration of NO from trial 1 to trial 2. We doubled the concentration of NO. And so what happened to the rate? Well, we can see when we doubled this, 1.25 to 5.0, right? What's happening there? Well, what we can do is we can say, okay, well, R1 was equal to 1.25, right? Times 10 to the negative 5 molarity per second. And then R2 was equal to 5.0 times 10 to the negative 5 molarity per second. And so what we can do is we can say, okay, well, what's R2 divided by R1? What's the ratio there? Well, R2 divided by R1 is going to be equal to 5.0 times 10 to the negative 5 over 1.25 times 10 to the negative 5. If you put that in your calculator, you should get 4. R2, right? Therefore, what we're saying is that R2 is 4 times bigger than R1. Well, what does that mean? If R2 is 4 times bigger than R1, that means that the order is 2, right? And so here, A is equal to 2, right? Basically, here, and O, that exponent should be equal to 2. And so, great, that's very nice, very easy, right? Now here, if, well, from trial 2 to trial 3, what are we doing, right? We kept H2 constant for this, right? And you have to, right? You can only change one thing at a time, right? And so we kept a constant for trial 1 and trial 2, but now for trial 3, we kept NO constant, and instead we doubled the concentration of H2. And so what happens to rate if we double concentration of H2? Well, what's happening here? Let's put that in our, let's think about it this way, right? R1 is equal to 5.0 times 10 to the negative 5 molarity per second. And then R2 here is equal to 1.0. Be careful, it's 10 to the negative 4 molarity per second. So when you put in your calculator, be careful, right? But again, we can just say, well, R2 over R1, what's that equal to? Well, if you put it into your calculator, if you put 1.0 times 10 to the negative 4 molarity per second, can you guys hear that? So please, if I am, doing something, please do not be banging on my door. I promise you, if you're watching this, I promise you, I'm doing something important. I'm trying to help some students. So, anyways, put into your calculator. Please also put parentheses around these because otherwise you're gonna mess up. And so what you're gonna get when you do 1.0 times 10 to the negative 4 divided by 5.0 times 10 to the negative 5 is you are going to get 2. And so here, right, what's happening? Now be careful, right? Don't just read this. R2 is double R1, right? R2 is 2 times bigger than R1. And so our order here is going to be equal to 1. Now do note this isn't A, it's B, right? B is equal to 1, right? Because that was for H2. And so overall, what we can say is that R is equal to K and O to the power of 2 and H2 to the power of 1. And so this reaction is second order with respects to NO and first order with respects to H2. And so overall order is third, actually, because it's 2 plus 1, right? And so that's how you do this. Hopefully that helps. Let me know if you have any questions. And let's see who's at the door. All right, you guys want to be in the video? Yeah.
What video? Is this your brother?
This was for AS Chem, and we were trying to, help out my AS Chem students. So
AS? I'm a TA for AS. How you all struggling in that class, bro?
Yeah.
How you all struggling AS Chem?
Yeah, nah, real ass shit.
Right. So y'all, please, if I'm doing something, do not disrupt.
Were you vaping?
Hey.